Hello everyone. We are continuing in Module 3 and I want to talk a little bit about the scientific method. So when we're done with this module, you should be able to identify the parts of the scientific method and how they work together. So observation, experiments, hypothesis, theory, and law. I wanted to talk about a couple of things before we get specifically into the scientific method. And, excuse me, these are things that you'll need to be aware of throughout the course, and I want to talk about them now because we will be referencing them in this discussion and in the discussion immediately following this one. And the idea here is that when we talk about things in chemistry, we could be looking at a variety of different representations. So we can talk about things on essentially different levels. The macroscopic level is what we encounter in the world around us. So each one of us is macroscopic. When we go in the lab, the chemicals we measure out are macroscopic. Everything we interact with is macroscopic. We can also talk about the particle or molecular level representation. So this is where we're looking at what are the atoms actually doing, what are the molecules actually doing. So we'll be going back and forth between each of these, between things we can observe directly, so things we interact with on the same level as we are, versus what are the tiny particles that make up the matter doing. And in general, when we do this, we'll be doing this in a symbolic way. So we use symbols to show what's going on. For example, we use letters to represent elements and compounds. We don't mean that to say that matter is made up of this sort of alphabet soup of H2O, so we have, if we zoom way in, we see these sort of letters. We're just doing that to make life easier on us as we keep track of things. So when we're balancing equations, when we're doing other things with chemical symbols, understand that that's a representation of either the macroscopic or particle level of what's going on. But the symbolic level is what we will probably be talking about the most, so just remember that it is representing something else. Okay, so speaking of atoms and molecules, just a really brief introduction to this, and we'll be using, we'll come back to this in more detail in the next section, but I wanted to introduce it now because we'll be using these ideas to talk about the scientific method. So for now, we can say that atoms are extremely small, indestructible particles that everything is made out of. And that molecules are combinations of those atoms that can act as a unit. So here we're showing a representation of a carbon dioxide molecule. So we can see that we have several atoms, 3 in this case, that are combined, and this whole thing will act as a unit. Now, in terms of why is it this way, why is the carbon in the middle, why is it this particular shape, those are things we'll look at later in the semester. For now, you just want to understand when we have a symbol of a compound, it's representing this sort of a combination. One other thing I should mention now, and this is something we'll look at a little bit more in Unit 4, is that molecules are not the only way atoms can do things. So we'll look at some other ways they can do things when we get to Unit 4. Okay, let's talk about the scientific method now. And one thing I want to let you know about the scientific method is that the words we use here, when we use them in science, they sometimes mean the exact opposite of how you might use those words in some other setting. Specifically the words law and theory. Okay, so we'll get to those at the end. To start with, in science is about observing the world. So we make observations about the world. We see something, we hear something, we smell something, and from that observation, we come up with some kind of a hypothesis. So a hypothesis is a potential explanation for what's going on. Now, to be a scientific hypothesis, it's important that it's a statement that can be proven false. If you have a statement, maybe something you believe, that you would not like to be proven false, then you should not treat it scientifically. So things in science are things that can be proven false. When you state a hypothesis, it should be stated in a way that there is some kind of experiment that could prove it incorrect. Okay, so once we have that hypothesis, we can then do some kind of an experiment to test it, to see, is this a true statement? Does this actually describe what's going on? And we can test and retest with these experiments. And if we look at things long enough and we have enough observations and experiments, we can formulate a law. Okay, now this is where the word means something very different in science than it does in our everyday speech. So when we talk about the law, we usually talk about something that if you don't do it, you get in trouble. So if you drive too fast, you might get a speeding ticket, for example. In science, that's not what a law is. In science, a law is just saying this is how it happens. So it's not that we have a law so that it does happen. It's that we make the law to say this is how it happens. This is how it happens all the time. And a law is just saying what happens. So when we have the law of gravity, for example, it's not like Isaac Newton is sitting there on the apple tree making sure the apples fall down. It's that's how it happens. Nobody's enforcing the laws of science. They just are. Sometimes when we get new experiments that we hadn't anticipated, we might actually revise these laws. So an example would be the theory of relativity changes how we talk about matter and energy. We're not going to get into that level of detail, but just be aware of that. Another thing that can happen when we test a hypothesis is that we can come up with what's called a theory. A theory is, again, a word that when we use it in science, it means something very different than when we use it in regular speech. So in regular speech, people might use the word theory the way we might use the word hypothesis in science. And in fact, I think the word hypothesis is a stronger word than the way theory is used in everyday life. So sometimes people use theory to represent kind of this loose thought of, well, maybe that's why it happened. In science, a theory is an explanation for why it happened. You don't get to call something a scientific theory unless you have had several lifetimes of scientific experiments pointing in that direction. You need to have evidence from multiple sources, from even different fields of science, in order to call something a scientific theory. Sometimes people think that theories kind of graduate into becoming laws, and that's not really how it works. Theories and laws are answering different questions. A law is telling us what happened. A theory is telling us why it happened. So just be aware of when we talk about the scientific method, these are what the terms mean. Okay, I want to look at an example related to chemistry. So the experiment that this is based on is that if you burn things inside a completely sealed container, you want to see what happens. So what's happening to matter as you burn it? And one kind of obvious thing you might ask is, how does the mass change? And when you do this experimentally versus just an observation, you notice something interesting occurring. And before we talk about the result, I want to talk about the hypothesis. So this is an experiment that was done several hundred years ago. And the hypothesis at that time was something called phlogiston. Now, you have probably never heard of phlogiston because we don't believe that that is a good explanation anymore. But the idea of phlogiston is that as something is burning, you have a substance within it that is escaping into its surroundings. So that is the theory of phlogiston. And what was observed is that when you are making very careful measurements, and we've already seen why that's important and how to do that, when you're making very, very careful measurements, it turns out that the mass doesn't change. So when you record all of the things that happen, all of the smoke, all of the gases that form when we burn something, those masses are, and the masses of everything you started with, end up being exactly the same. And when you look at that result and you look at, well, sometimes if you have a metal, it gains mass, it just doesn't actually work as a good theory. So phlogiston was eventually discarded as an explanation for what goes on. But with these experiments, they were able to come up with a scientific law, and this is an important one. It's called the conservation of mass. So this law states that matter is neither created nor destroyed in a chemical reaction. And this is one we will be using throughout the semester as we look at chemical reactions. We will be assuming that this is true, and we will be using this law quite a bit. And the theory is that, so the explanation, so the what is that matter is not created or destroyed. The explanation is that matter is made of tiny particles that can't be destroyed. Okay, so that would be a way to explain what was observed. Now, if you look at that statement carefully, you might think about, well, that doesn't have to be exactly that way. For example, why do we have to have particles as the atoms? It turns out that there are other scientific laws that are also explained by this theory. So one of them is the law of definite proportions, and that will be something we'll see in the next section where that comes up in the formulas of compounds. So atomic theory explains more than just that one law. There's actually 3 laws that go into atomic theory. But the idea is that the explanation, so atomic theory is explaining it, and this theory is over 200 years old, and yet atoms themselves were not actually observed until within the last 50 to 60 years. So we now have the technology to see atoms. However, the idea of atoms with a basis in observation and experimentation is very, very old. Okay, so sometimes a theory, once we have the technology to see things we couldn't see before, sometimes it actually becomes more of an observation than a theory. Okay, so that is it for this this section of the module. So go ahead and complete worksheet 3.2. If you have any questions on it, ask those on the discussion board, and then proceed on to 3.3 when you are ready.